Welcome everyone, and thank you for joining us today for the webinar titled Graphs for Cybersecurity. My name is Sabine Seitz and I'm part of the marketing team here at Neo4j. And I'm joined today by Gal Bello, pre-sales engineer at Neo4j. A few housekeeping items before we get started. We invite you to submit your questions throughout the presentation using the questions tab located at the top of your screen. We plan to answer questions from the audience at the end of the webinar, but if by any chance we don't get to answer them, please mail them to webinar@neo4j.com. Also, I want to let you know that this webinar is being recorded. With that, I'll go ahead and hand it over to Gal.
Thank you, Sabina. Thank you very much. Hi, everybody. Gal here, calling you to this webinar from Israel, Tel Aviv, where it's pretty hot and sunny and warm. So with no further ado, let's go ahead over the agenda for today. So first of all, I'm going to introduce myself and say hello. Then we'll talk about cybersecurity. What is the problem with cybersecurity? We all think we know this problem, but we're going to look at it in a different perspective, more of kind of a data perspective. And then we're even going to show some interesting numbers about the market, of course, the business aspects behind what's going on in cybersecurities. Then hopefully most of you are familiar with Neo4j, but we are going to present a little bit about our company, some background, what makes our technology so unique and special. Then we're going to talk about graph concepts and graph theory, a little bit about graph theory. I'm sure most of you engineers out there are familiar with Leonhard Euler's work on graph theory, so we are going to see a slide or two on that as well. And then we'll just present what's so important about modeling your data in a graph way and not sticking with the same columns and rows that we are all familiar from relational databases. And we'll show kind of a demonstration how we've modeled our data in a graph way, also specifically for cybersecurity. And then we'll show that how we're doing that in Neo4j. Like Sabina has said, we have question and answers at the end, and then we'll say goodbye and hope to see you in the next webinar. So with no further ado, like I said, I'm Gal Bello. I'm working in Neo4j for more than a year and a half together with Sabina as a field engineer. Feel free to follow me on LinkedIn, to add me, to contact me if you need any kind of information on Neo4j, also on Twitter. So very, very happy to be here with you all. So cybersecurity, everybody knows how important that field is for enterprise company, for small, medium business companies, even for individuals, our cell phone, our laptops. We have so much information, which is super, super critical for us, super safe. And we want to make sure it is safe for us because all of the dangers out there for hackers and malware, etc. So one of my favorite TV series, Mr. Robot, has presented what can happen and how is a cybersecurity attack looks like. Sorry. So here you have 1 minute and 20 seconds of a cybersecurity. Yeah, crazy stuff. So hopefully most of you are familiar with cybersecurity and how is so important if something this happened to you and your company. So let's just go over a definition of cybersecurity, just to make sure we fully understand what's on stake here. So cybersecurity is the practice of defending computers, servers, mobile devices, electronic systems, networks, and data from malicious attacks. I've marked data here because we in Neo4j, I'm sure most of you understand the power of data. It can be harmful power, of course. It can harm your company if passwords are being leaked, accounts, credit cards, images, emails, any kind of sensitive information that's being leaked out. We all understand the power behind data. And this is exactly where cybersecurity defend firewalls are come into hand. And let's go inside some numbers. $112 billion. That's the cybersecurity market worth these days. That's a huge number. We all understand what's going on behind the scenes, how many companies are trying to solve and assist you as companies to overcome and to protect yourself from hackers all around the globe. 3.9 million. That's the average cost of a data breach across small, medium businesses. If you imagine your small business losing passwords, things happen to him. He can lose his customers because of that. We all heard about Walmart, eBay, Amazon, Alibaba. Almost any kind of big company has suffered from huge breaches and needed to request you to change your passwords all over again. So imagine if you're a small business, how valuable for you is $4 million. $6 trillion, around $6 trillion expected to be spent on cybersecurity by 2021. That's a huge number. This is one of the main pillars in the high-tech market these days. 39. Every 39 seconds, there is a hacker attack out there. As we already spoke, there are at least, according to my calculation, around 12 different hacker attacks out there. My assumption is even more, but around 39 seconds, there is an hacker attack. I'm sure most of you have felt or received kind of a fishy email or a fishy application that you needed to click on or something like that. So that happens a lot. 92% of the malware is actually being delivered using an email. Like myself, I'm sure that you as well have received kind of dozens, at least, emails from PayPal or for any kind of banking account or banking of software that told you, listen, your password or your account has been breached. Click here to change your password. And hopefully most of you have not clicked that button, because once you click that, that's a phishing email. It may lead you to a page that looks exactly like PayPal's page or Alibaba's page, but of course, it won't be the same page. You'll deliver your personal details, and that's it. From that point and on, your email has been, or account has been hacked. So 92% of the malware is being delivered by email. Please look into that as well with your companies. 57% of cyber attack actually attacked target enterprise companies. That's a huge number. That's the majority of attacks are going into enterprise companies. And because we all understand the huge value for the hacker once he attacked this kind of enterprise company, it can go banking, if he into finance, or of course military services, intelligence, any kind of huge companies, government companies that are being hacked, the damage will be much further. So we see the majority of attacks going towards this direction. So if you are guys working in enterprise, please spread the word how important it is to be safe from cybersecurity in your companies. 39% of cybersecurity breaches are actually due to human error. Most of the people do not understand that and think that it might be wrong with the server. Maybe it's a restart, maybe it's a leak hole or something, but actually 40% is coming from a human error. It can be from the emails that we already discussed. It can be from not blocking a specific port and changing the numbers, or entering an easy password, or maybe not entering a password for the Wi-Fi of his company or something like that. So human errors are super critical in this effort of us protecting from cybersecurity. 60% are people experience phishing or social engineering attacks. That's a huge number. It means that the majority of people have experienced something like that. I'm sure, like I said before, most of you have already received kind of one or two emails at least that saying something to you, or maybe download this application and click over here and there. You'll get free coins or free money, or you won something in I don't know, in a sleeping account somewhere in Asia. Please be aware that it can be a phishing email, of course. So when we think about the problem, it's very, very clear to us that there is a problem here. But when we think about what is the problem when we come to solve, once we had an attack of cyber attack, what do we do then? So we capture the problem is this: cybersecurity analysts have to capture, store, analyze, and potentially share vast amounts of rapidly evolving information. We all know that the information is being exponentially growing as we speak. But once we had that breach, we want to understand exactly what is the damage like. Where is this hacker can grant access to, from which account, from which email, from which project, which document is being exposed. So all of this kind of growing information, we want our analysts to be on the safe side and know exactly to tell us, okay, what needs to be done to secure this and this data. And they are going to do that by leveraging connections in the data. They want to understand how is data connected one to another. And this is exactly where Neo4j enters the picture. Neo4j technology is not only about saving your data in an ACID compliance way, it's about saving the connections between your data. If we were familiar from until now only on rows and columns, the properties and name values, even if it's for big scales like Cassandra, Elasticsearch, MongoDB, when you're talking about graph database, what's really important to you is being able to connect the dots between your data. And looking in these connections that we see here can assist you and your teams secure your data while fighting cybersecurity. So like I said in the agenda in the beginning, I'm going to talk to you about Neo4j. For those of you who are not familiar, we are here for a while now. That's actually almost 20 years from since Emil, our founder, has established Neo4j up in the north in Sweden. Since then, we grew pretty far. We had a long way until recently we've released Neo4j 4.1 version, which is a huge milestone for our company. So in 1 minute and 20 seconds, what is Neo4j? There you go.
Neo4j is a database. Unlike traditional databases, which store data in rows, columns, and tables, Neo4j has a completely flexible structure. Most importantly, Neo4j saves the relationships that connect your data. With Neo4j, each data record, or node, contains direct pointers to all the nodes that it's connected to. For example, if Bob is friends with Jane, that Bob node points directly to Jane through a stored relationship. This network of nodes connected by relationships is known as a graph. Most other databases, even more recent NoSQL types, don't save relationship data directly. They can figure out connections, of course, but they usually do this by searching through a separate data structure called an index. This lookup process, which has to be done repeatedly to find each connection, is an expensive extra step that makes these databases inherently slower than Neo4j for relationship-intensive queries. Neo4j avoids these index lookups because its native storage layer is a connected graph. That's why we call Neo4j a native graph database. Over the past decade, Neo4j has made graph databases a key technology powering modern applications for hundreds of Fortune 500 companies, government agencies, and NGOs. Neo4j is used to detect fraud, enhance artificial intelligence, manage supply chains, unify data silos, and much more. Visit neo4j.com to learn more, or take a guided tour of a graph database use case in the free Neo4j sandbox. Neo4j, the #1 database for connected data.
Great. Hope you learned a thing or two about Neo4j. So like I said, Neo4j we've established in Sweden by Emily and 2 other founders. We are around 400 employees so far. Our headquarters are in Silicon Valley, London. Sabine is located in Munich with other great team over there, Paris and Malmo. We have around 400 global enterprise customers. You have seen in the video the huge logos for starting from eBay, Cisco, LinkedIn, Microsoft, Intel, NASA, almost every kind of company that an enterprise company that once start working with graph databases have contact or used Neo4j or purchased Neo4j. You've seen a list of partners here, but it does important for me to say that Neo4j can run on almost any kind of machine that you have, starting from your personal laptop, going all the way from virtual machines, on premises, of course, any kind of cloud databases, if it's Google, if it's Azure, if it's AWS, of course. And we also have our new service, which is graph as a database called Aura. You can go ahead from Neo4j Aura and look that up. So I've mentioned before that it's so important part of connections when we're dealing with cybersecurity. And when we see these kind of free modeling examples, we know that if somebody knows another guy, or if somebody has bought an item or has viewed another one, we strongly understand that it's not only our ability to, our need to save, the node itself or the data itself. We want to understand the connections between them. And even, let's take, for example, any kind of e-commerce that want to recommend you to buy an additional shirt for your gaming or a scarf or something like that for your soccer team that you're a fan of. If they're going to do that by supporting only the data itself and not the connections between the data, it won't be sufficient enough. That's why we see the recommendation are being built on graph databases. Use cases, of course, we're starting from real-time recommendations, like I mentioned before, that eBay already, we saw that. Fraud detection, like we are talking about today. We have governments, we have military, we have surveillance, any kind of huge organizations that want to deal with cyber attacks or fraud attacks, from finance to hackers, everything that you model these kind of things in a graph, it makes your life much, much easier. Of course, everybody knows now with the pandemic and the COVID-19 situation, you all seen that the news articles that saying how far can the COVID virus spread. If you met someone on a train, how will it go? Everything needs to be modeled in graph way. I'm sure everybody's now totally understand the key of using a graph databases by dealing with such events. And if you think about cybersecurity, if something happened to one of your documents or one of your emails, you really want to understand how this is going to affect your company by only one email breach or even one password leak. How is this going to reflect in your entire company, in your entire accounts, documents, private projects, etc. And we will see that in the data model itself. As for our technology, as you've seen in the video, our native graph, we are a native graph technology because we save the data itself. The connection and the relationship between the data itself has been set, is saved as a kind of a pointer adjacency between nodes. So if you go into one node, our ability to hop to the second one is almost in millisecond. It's not only about 5, 10, or 100 joins. We're talking about millions of hops between nodes that can actually happen in real time. And this is exactly why we save those data in pointers that connects the data in our memory, instead of saving that in rows or column and then have to do kind of a joins like you're familiar with tables. And if you see, we have the graph algorithm. That's a new library that has been released lately. It's called GDS, Graph Data Science, that you can use over Neo4j. On your data, you can use many algorithms that's going to help you. Also for cybersecurity, also if it's similarity, if it's between us, if it's a shortest path, all kinds of paths that you want to connect between the hacker itself or a specific email to another node or another connection in your data. You can use these algorithms, and you can do that pretty easily by using the data that you already have in Neo4j. This is exactly kind of thing that can assist you while working with our platform. So let's talk a little bit about graph theory and some concepts of graph. I'm sure most of you are familiar with the 7 bridges of Königsberg's problem. We go back 270 years ago. Euler needs to deal with a situation where he has 4 islands and 7 bridges, and he is getting a task to solve. Rather there is a route that you can go on all bridges without repeating it twice. At the end, if you look at the right side of the slide, you'll see there is a presentation. He represented the problem kind of a graphy way. We see those 4 nodes that we can call it today, and we have those kind of relationship that connects the dots, connects the nodes between those nodes, and we can enrich them with additional data, of course. And while we attack the problem in a graph way, we can actually get a much more easier solution to these kinds of problems. So which kind of graph can we find? Anything can be in graph. It's starting from a water molecule. It goes all the way to the internet. Larry Page and Google have based their PageRank algorithm around the connections between a web page to the other and the ranking between those links. So everything is actually can be represented a graph. We talked about the COVID-19. We talked about the spread of the pandemic itself. It's a graph. Even when searching for a cure for the pandemic, you find people using graph to find the correlation between a specific DNA to a specific drug that can be suitable for, etc. Game of Thrones, I'm sure everybody is already familiar with the connections. How is everybody connected to everybody in the series? So we see here a good representation in graph. We talked about the value of graph databases, but let's go back to relational database. We see that we have the data in columns, in rows, but what we want to do is not only have the data itself, we want to connect the dots. We want to have these kind of pointers that connect them to enrich our data and then tackle it. So we take the traditional database, we move on. After several years, kind of 10 years ago, Hadoop came along, Spark, other sharding application, Cassandra that you can use, and you can run long running queries and aggregation and filtering, but that's still not going to save the relationship between those nodes. And when you think about cybersecurity, and I know that if something happens to your enterprise, to your account, this solution should be coming from you in a real-time way. You don't have an hour, you don't have 2 hours, you don't have a day, or of course not a week or two to keep on looking exactly what's the effect of an email breach, what's the effect of a password breach. You want to see those connections and you want to see that real time. Doing that with Neo4j or doing that with a graph database can exactly assist that. One additional thing that you can do, let's say your data that you're going to deal with once you're going to think about your cybersecurity data that you can handle, you're going to have that in in this example, in 4 different ways. You can skip some of the data in relational databases. You don't need to throw that away. You have the white column, you have Elasticsearch, you have MongoDB, you can use your Spark, you can use everything that you need, throw everything into Neo4j, and actually just use Neo4j kind of a data lake for your entire data. And now you have the ability to connect between those different silos. This kind of ability was not able for you once you have only one kind of database. And when you do everything in a graph, you can connect between different silos, and that can enrich your understanding of your data much more because of these new functionalities. 2 graph concepts and components, that I'm sure you're familiar with. One is a node. We understand how a node works. We understand that's the element that construct our graph, and we have the relationship. In Neo4j, a relationship has to have a direction between one node to another. It can't be with one node to an empty space. It needs to be between 2 nodes, and it has to be a specific type. So we'll be able to understand what is the connection between N to her car. We now know that connection is owns, and we see that we see the arrow as well that emphasizes that N is owning the car itself. So these are 2 components that you need to understand before diving into Neo4j. Here we have kind of a short example of a data model. We see a user, we see his account ID, we see another account, we see the branches, we see the first name of that user, we see the cars, what he is driving on, he owns, etc. So we talked about how important it is to represent our data into graph modeling, which is totally different for what the modeling that we are already familiar with using the current databases that you have, starting from relational databases, even from Mongo and Elastic and other big data scales databases, but none of them has the ability to show you those relationships. So let's go over some example of a graph modeling. If we go ahead and see some law enforcement modeling, for example, we see that we have in the center, we have suspect, we have various kind of nodes or kind of labels. We have police reports that you can use with story, arrest of the suspect, convictions, early convictions, financial records, addresses. All of these different silos, different information is coming into one big database, our graph database, and you can connect these dots pretty easily if you model your data that way. Another good example of modeling fraud rings, we see different kind. If you look at those colors, we see bank accounts. We even have some suspect, these kind of hacker logos and notes. Sorry, we see the phone numbers, social security numbers, unsecured loan. Everything is connected once we model our data in a graph way and not in a table way. One last example of a very good governmental data model. We see a mother, we see a father, we see their United car, we see their kids, we see their house, emails, IDs, phones. Imagine if you're a government and you want to control, you want to understand what happens if this lady personal account has been hacked, and then you understand that she's connected to this guy, he's her husband, or her kids, or his email, his email. Now you can see those connected dots by using a good data modeling. So let's take this further and see how graph data modeling specific for cybersecurity can assist us. So we have our employees in our company, starting from A all the way to Z. Of course, those employees are working in a department. For example, the department number is 100. We see that those employees, if we want to enrich the data, sometimes companies has it, sometimes not. Maybe the finance department has it. We have these employee bank account. We have his address. We have maybe his personal car or personal account, etc. We can enrich our data graph with more and more data if we have it. Those department is working on a project. Every kind of department is working on a different project. Sometimes many departments are working on the same project. So let's, for example, think what happens if this employee A is being hacked. How many people are going to be affected by such a cybersecurity on employee A? Okay, so we see on the left side also department 200 is working on project A, project B, 300, etc. We can enrich the data in our graph even more. We see that for each project we have documents. Some of these documents are very, very sensitive, and we want to see the connections between, from one end, these document all the way to department and even to the bank account. And now when we model the data in a graph way, we can see those connections. This project is going to be developed, and it's going to be, at the end, it's going to be published. It can be published, in this example, on a production server. If this server is being hacked, if from one end we have a document being hacked or an employee being hacked, all the way we see the connection all the way to the production servers. And this is going to be very, very crucial for us when we deal with cyber attacks, to understand, like we saw in the movie of Mr. Robot at the beginning. We want to understand which server are under attack here and at stake. So if we see this project C is being deployed on a specific server, we want to know that connection. So we add that to the model as well. Now we want to enrich those models, and we can give those relationship even a type, like we saw before. We see this project C is being published on those servers. We can see that the project is being saved on those documents. The one that manages this project is this department 100. Employees works at department 100, etc. Of course, you have the ability to save it as much as you want, but I do recommend working with best practices that Neo4j supports, kind of best practices to how to model your data. Let's take it for the final stage to see exactly what a cybersecurity model will look like. So we have the hacker on the left side. He's been throwing emails, those phishing emails all over. Maybe one of those emails is being directed to an employee in a company. Then we saw that 92% of people have been engaged by this kind of emails. And now we see that if this email is actually accidentally opened by employee A, we can see exactly until where the connections are going to lead starting from this employee all the way to the servers, to the document, maybe the bank account, etc. So let's go ahead and see some the example of the use case that we want to see now in Neo4j. So just to summarize, we have the department 22 in the middle. We have employees. For each employee, we have addresses. We have bank accounts. We see the emails like we saw before. Some phishing emails are being thrown. Project B, C, documents, published on servers, etc. So we are going to move now to demo. Sabine, if you want, we can take 2 questions or so before we're going until I load our database.
I think everybody is very keen to see the demo, so I postponed the questions to later.
Okay, good. So I guess a couple of words about what we see here. So this is Neo4j Desktop. It is a free download software that you can use with your laptop, with your server. It's actually here to assist you learn about graph databases, to learn about Neo4j, to develop your queries, to try it with yourself. We emphasize and we encourage our customers and also just people around the community to go ahead and download Neo4j Desktop, create, like I've created here, several projects. For each project you can use and create your own databases. That's for free. You can use it, you can enrich your data and just go ahead and do that. So here what we see is I've created a cybersecurity webinar project. I've created 2 databases. One is called 4.1, the other is called cybersecurity 4.11. We see the nodes, we see the relationship. I've already entered some nodes. I'll show it in a minute, the script for that. Let's just see in a minute. Okay, so if we look at, hopefully some of you guys are familiar with our language. It's called Cypher. Cypher is the language that you can query Neo4j with, you can insert data with. It's very, very easy to learn, and you have all kind of documentation in our website to assist you doing that. So here in the beginning, of course, I've created several indexes for us to have a quick quick query if you want to withdraw, for example, employees, departments, alerts, server types, databases, project, email. So every one of these entities have an index now. I've created some employees. I've just simulated some stuff. It doesn't really matter because all of this is not real, of course. Every employee has its own email. I'll show in a minute. I've created some servers. Those servers has unique UUID, so they can be differentiate from one another. We have 2 kinds of server types, staging and production. What do we see here? I see server and server type relationship. I've created the relationship between a server. Some of them are going to be reflected as staging. Some of be reflected as production. I've created some alerts for us. You can see that here with a unique ID as well. Some priorities for these alerts, from not important all the way to critical. This is just my personal imagination, which I created this data set. But if you are working on solving cybersecurity and trying to model your data in Neo4j to solve cybersecurity issues, please keep those best practices for modeling. Make sure you contact us for us to assist you doing that. So this modeling is only by my private imagination. So I've created here a couple of priorities for these alerts. And then I've created another relationship between a priority and an alert itself. It's called with level, as you can see. Hopefully that's not gibberish to most of you out there. Departments, I've created several departments like we've seen before. I gave them names from HR to IT, all the way to QA. I added relationship from, let's say, from engineering all the way to automation or IT. So we see those relationships in those departments. You can see that as well. I've connected between employees to departments where they work. So we see those connections called relationship story calls works at. Projects, we have many projects here starting from Katan, Venado. You see all kinds of projects over here. Alerts plus project relationship, I've connected the alerts to the project themselves. And what do we have here? Employees being connected to the project. And actually, this is it. So now we can go ahead and we can see, first of all, kind of our Neo4j browser. That's what you see here. Here I can just use my browser to browse my data that was already inserted into this Neo4j. I see that I have 573 nodes. I have 4,870 relationship type. Just for example, let's see some around 25 emails. I can see those emails here. I can see that for every email I have an attachment. Rather, I have the attachment that's true or false. I have a date that was sent, this email. Who is it from? Let's say from this email address. Who is it to? Over here. Sender IP, that's super important for cyber because we all know that the IP is the ID of usually the attacker, and we have the ID of the email itself. Okay, so this is just an example. Let's see the schema. You can also use that. If we look at the schema, we see that you have the priority. Every alert has with level of priority. Every alert is part of a project. Every alert is also applied from a specific server, meaning that if something happened to that server, I've seen this alert, and now I know the severity of this or the priority of this alert, and I know which kind of projects are going to be affected by this alert. If we're moving on, we see that this project, who are the employees that are working on that project, this server specific is part of a server type. Okay, it can be production or it can be staging servers. We see who has the authorization on these server type. Let's see, we see here a department as well. We have a databases on the side and we have some emails on the side which are currently not connected to the schema. Of course, every department has its own sub-department off, so that's more of a schema issue. So let's just go over and query some stuff on the data. Let's take this, for example. Okay, so let's go ahead and query. Sorry, it's an M. We are querying for a project. It's called Project Belko, and we want to see who is related to that project if something happens, if there is an attack. So if I double click that, I can see who are the employees. Here I see just 100, not to kind of explode the front end. I see 100 employees are being connected to this project. If I click this one, I can also see on the bottom the email, and I can also see the ID of that specific employee. Let's say, for example, this email 1885@email.com is being hacked. I want to see who is he connected to. I can just click here. I see that he's connected to what's that? Works at this employee. He's working at this department. This department name, as we can see here below, it's automation. So if something happened to that project or that email, everybody related to this department automation, every kind of other employee related to this department is going to be in danger. And I will need to do that if I'm going to kind of shut down emails or be aware of dangerous emails that have been unsecured, etc. I'm going to double click automation to see what he's connected to more. See, that's it for now. Let's take another example, another query. Let's, for example, take this employee. Now we can query by employee email address. We see this employee here. Of course, I can tweak it if I want to say that, for example, the email will be shown or the ID itself will be shown, or maybe the inner ID of Neo4j. I can tweak the size. I can tweak the color. That's just more place for you, visualization place. Sorry. So let's go ahead and see this employee over here. I'm going to double click it, see that he's been working on this project called Project Hamed. And in addition, he's been works at R&D. I know that for sure that R&D is an important department for myself. Let's see who is connected to that department. If I click here, I see all of these employees also are being connected to that. So if something happened for that email, all of these will be in jeopardy. Let's just take another one, click that. I can see that he's also working on Project Hamed. Everybody all together. Let's see if we have anything more critical here. Let's see exactly what's going on with servers. I know that I have my servers, and my server, the one that the places where I run and where I save my code, and this is super critical for me to show what happened. So I'm going to query by using an ID of a specific server. I'm going to double click it to see which kind of type is that server. I can see that, I can see that this type is staging. I want to see which is connected to staging. I can see the other servers that are going to be connected to staging. Let's go ahead and just query by server type and see production servers. Just write down. Oh, now I can find my server type. I want to see if something happens to it, who is going to be affected by that. Then I see all of these servers that are type of production up. It means that these servers are going to be super critical for me when I'm going to deal with cybersecurity. It means that any kind of project that is going to be related to these servers, I will need to be extra careful. I need to be a more kind of conservative about. Sometimes we even want to do kind of our shortest path. Let's see how that works. Hopefully most of you are familiar with shortest path. So what is shortest path? I'm trying to find the shortest path of a graph between one entity. In this example, I'm trying to find the shortest path between a specific server and a specific employee. Why is that? Let's say, for example, that this employee had something or left the company, or I might be suspicious at, or maybe, I don't know, something happened is he became a criminal and I heard from the police that he needs to be blocked away. So I'm going to find from this employee to a specific, very, very important for me server, I'm going to run this syntax, find the shortest path until 15 degrees between these two. I'm going to filter out by using a specific UUID for the server, and then the specific employee will be filtered by his email. Then if I run that, if I'll run that, I'll see that I can find the four dots that connecting, starting from the employee itself. I can see that here. Here he is all the way to that important server. So if I need to stop that server, or if I need to understand which kind of environment he's going to be reflecting on, if it's staging or production, I need maybe to think about cutting everyone related to Project Berko in this example, or maybe cut this alert, or maybe cut this server, etc. Hopefully that is understandable. So we are a little bit behind schedule. I want to show you another thing that's called Neo4j Bloom. Neo4j Bloom is actually a kind of a software visualization tool that has been developed by Neo4j, a great one, mainly for analytical teams, mainly for business aspects that want to observe their data. It's not about Cypher query, it's not about technological queries. It's more about how you can browse, or let's say inspect your data in a more of a visualization way, which is very, very helpful for you guys. So let's just open that with Bloom. You can see that that's also free, part of the Neo4j desktop, so you can go ahead and use that. So now we see Neo4j Bloom. I'll give it a min. Let's say, for example, that we are going to search, for example, for this employee. I'm going to take this, I'm going to run it down over here. See if we find that. All right. Employee with email, and then I'm going to paste that. Click enter. Give it a minute, and then we see that. So what we see here is actually the employee itself. We can double click that and see what's the relationship for him. We see, first of all, we see for that employee, we see the fields, we see as an email field. If I need to edit this email, I can do that by using this clicker here. If I want to add or just edit another field, I can do that over here as well. From relationship, let's see who is connected. He's working at R&D. He also works on Project Berkoy, and he manages another guy that's been working. That's 1146. Let's click that and see exactly. See if we open that as well. And if we'll go for him, we'll see who is he related to. He's working at R&D. I can double click that to open the R&D. I can tweak also the icons, and I can also tweak the size of those kind of icons. Let's see. Let's say, for example, I want to add priorities to my screen. I click priority, see many priorities, and what I see here is that the critical has been mostly enlarged. This is critical over here. It's more large or bigger than the other one. I can control that by going to rule-based and see that the size has been doubled. I can, if I want, I can just remove those rule-based. For example, just give me a sec. Exactly. Okay, so I can also use Bloom if I want to investigate, for example, what's the connection between critical and this employee over here. Let's see if he has connection. Double click. I'm finding a path, shortest path, and I see that these are the connections between this employee over here until a critical alert. That's the alert specific that has connected to this email that I was addressed, and this was only been made by one click to show, like you saw, just right click the path, shortest path between the two. So I wanted to show you this as well. You can control, of course, the colors, the sizes, the icons. You can control all kind of perspective, but this will take more time of me to show you what else that you can do with the Bloom. So what we have seen so far, also from Bloom and also from the Neo4j browser, that how important it is for you to first model your data when you think about cybersecurity in a way that's going to be understandable for you, like we saw here, like we described here. Think about the use case that you want to emphasize. Think about the solution that you want to grant while dealing with attacks, while dealing with specific cases that you can imagine that going to happen to your company, to your account, to your enterprise, etc. And just go ahead and just model that in Graph and get the best value from Neo4j. Sabine, I think several recommendations I have for the guys here. First of all, like I said before, go ahead, download Neo4j, try it with your own hands. Nothing feels better than this. Instead of those presentations, you can just go ahead and try that. It's for free, also for a user on your laptop. Go ahead and learn it. You can go for our Graph Academy of Neo4j. You have training sessions. You have all kinds of video in the YouTube channel. I'm sure that you can go ahead for YouTube and click Neo4j. You see many interesting things. Go ahead for the Graph Academy, learn, do the certificate, and enjoy it. Join us for our Slack channel if you need any help with any cipher queries on anything that you need, graph data modeling, any kind of use case that you have. You can join our users Slack channel. That's for free as well, or just contact us either from what Sabine said before, the email that Sabine mentioned, or you can go ahead for our website and contact us there. Most importantly, enjoy Neo4j, get the best practices out of it, and welcome to the Graph world.
Thank you, Gal. Just a reminder, we will be sharing the recording and the slides after the after the webinar, so no worries about that. We have a lot of questions, but are almost at the top of the hour, so I will go ahead and pick some that appeal to the broadest audience. Let's see. One is about visualization. Can you talk again, please, about Bloom, but also a bit about Linkurious?
Linkurious. Yeah, so Neo4j Bloom is a proprietary software developed by Neo4j. You need to purchase that, part of a license, of course, and that's actually meant for more of a business perspective or analyst perspective. You can write Cypher's queries behind the scene while using Neo4j Bloom, but actually this is not the intention of Bloom. Bloom is here to assist you investigate, to assist you if you want to inspect specific nodes or tweak with the colors or show your analytics, kind of find paths or control visualization. And the difference between Bloom is Linkurious is that Linkurious is actually a different company. It is our partner company, but it's a different software. You can use that as well. It's also a great tool. But Neo4j Bloom is kind of a more analytics/business tool, while Linkurious is more, you can do many tweaks with open code behind the scenes. You can, of course, use Cypher queries behind the scenes. You can use Linkurious to do third parties, iframe, which you cannot do with Neo4j Bloom as well. So there are some tweaks. If you want more information, you can go for a browser Neo4j Bloom website, and you can try that yourself as well. Hopefully that answers.
One more question is, can Neo4j detect an attack in progress?
So that's actually something we leave for the application, for your application to do. What we can do is, if you detect, like I described in my model, if you notice a specific alert from your alert system, and then you have kind of a service that's always looking into Neo4j, rather this alert is already inserted into the system. If it is inserted, then who is it connected, from which server it arrived, etc. Then this is where Neo4j will come handy. But Neo4j is not a monitoring, for example. It's not a cyber platform that's supposed to alert this situation. It's more of a, you will need to use that to control your data, to understand how is data connected from one node to another, and what will happen once a specific event will happen. It's not a monitoring system. Hopefully that will help. That will make some sorting.
We have time for one more question. So let's take this one. Can Neo4j handle large-scale transactions? And if so, how many transactions per second?
So, of course, that is very, very dependent on the spec of the server itself. Whether you're using a single instance, whether you're using a cloud, whether it's a cluster, it really, really depended. But I've seen from projects I've been developing with my customers, I've seen more than 100K per second, even 200K per second. But it really, really depends on the memory and the spec itself of the server. But when we're talking about big scales in Neo4j, it's not just saying big scales. We're talking about billions. We have customers like NASA, like the US military, that are dealing with hundreds of billions of nodes. And while they're going to query those nodes, they do that in parallel in thousands of queries per second. And of course, they are dealing with huge amount. And still the data is very, very scalable. The performance is huge and very, very quick. So I totally say it really depends on the situation, the cases, the data size, the server. So we need to just, if you need more data, contact me personally. I will do my best to give you an exact estimation.
Thank you, Gal. So we are about at time, at the top of the hour. So I just want to thank you, Gal, for presenting and doing, in particular, the demos. And thank you to our audience for joining us today. Have an eye on your inbox. We will be sending links to the recorded presentation and to the slides. With that, I wish everybody a great day and see you at the next webinar. Bye-bye and stay safe.
Thank you, Sabina. Thank you, and thank you, everybody. Thank you very much.
Bye.